Okay, so here in section 2.4, we're going to start talking about something that they will refer to as kinematic equations, okay? And kinematic equations come into play in multiple different aspects. We can use our kinematic equations to find acceleration, to find velocity, to find displacement, all of those things. So as we start looking here, we start talking about constant acceleration. And all the things that are highlighted, you're going to want to take the time to put on your formula sheet. And yeah, I know there's a lot to them, but they're going to come in handy throughout the rest of the course, okay? So here we start talking about average acceleration, which they're just going to refer to as acceleration being final velocity minus initial velocity all over time, which we know from last section, right? But they also go ahead and they actually manipulate this using algebra, and that's all they've done is just manipulate it using algebra to solve for just their final velocity, which is just v. And doing some algebra here, what you would come out with is that v, which is final velocity, equals v sub 0, which is initial velocity, plus acceleration times time. And again, if you look at the units of acceleration, which is meters per second squared times the second, what you're going to find out is that things cancel out, leaving you with just units of velocity, which would be meters per second. So it's again interesting how the units do work out to give you what you need. So this is one thing that you're going to want. V equals v sub 0 plus a times t, where a is acceleration, t is time. Average velocity being displacement divided by time, so basically final position minus initial position, all divided by final time minus initial time, which is actually, again, using the a little bit of algebra, they're going to come out with x equals v times t. So displacement is going to equal velocity times time. Here they talk about the average velocity is the midway between the initial and final velocity. So average velocity is the midway between initial and final velocity. So in other words, initial velocity plus final velocity divided by 2, or 1/2 v sub 0 plus v, is going to give you your average velocity, okay? Only applies if the up here, section or equation 2.4 and 2.6, they only apply if the acceleration is constant. So all this is assuming constant acceleration, all right? All of this is assuming constant acceleration. One of the other formulas that you're going to want is x equals v times t, which is also the same as 1/2 v sub 0 plus v times t. And if you notice that all they've done is they've taken this formula from up here, the 1/2 v sub 0 plus v, that was v, plug it in right here, and that's how they come up with this. But again, it's all formulas that you're going to want going forward. And later on, we're gonna give you formulas, and we're gonna refer to them as the kinematic equations. Here, it's just telling you what everything stands for: displacement, acceleration, final velocity, initial velocity, and elapsed time. So in this example, all right, in example 5, it says the speedboat in figure 2.8 has a constant acceleration of positive 2 meters per second squared. If the initial velocity of the boat is 6 meters per second, find the boat's displacement after 8 seconds. And, again, it comes down to, because they're telling me it's a positive number, we're assuming it's going to the right, because that's by convention, to the right is positive. And you always kind of want to start by just jotting down some of the stuff that you know from the problem. So here we got a couple of pieces of information that we would want to take into account. So you got this right here. You got positive 2 meters per second squared. That's your constant acceleration. You've got your initial velocity, which is positive 6 meters per second. And you've got that it's happening for 8 seconds. And they want to know what is the boat's displacement. Okay. Well, if we're trying to find displacement, we're looking for an x because that's how we refer to displacement here in physics, right? So you're trying to find x, that's our question mark. We've got our acceleration, which is going to be positive 2 meters per second squared. You've got your initial velocity, so we say v sub 0, and that's going to be positive 6 meters per second. And we've got a time, which is going to be 8 seconds. And knowing that we're trying to find x, right, we would want to kind of come back here and we would want to say, well, what's the only real formula that we have, or what do we have at our disposal that might be able to help us? So when we come back here and we look, you've got a couple of different things that play into this, and you say, okay, well, I could use x equals v times t, which would be 1/2 v sub 0 plus v times t. And that's really the only one that we would have, because even here, if you look at it, x equals v times t, you would have to still use v equals 1/2 v sub 0 plus v. So what we're going to do is we're actually going to use this formula right here. All right, we are going to use this x to find our displacement. But 1/2 v sub 0 plus v times t, well, we have the v sub 0, and we have the t, and this is what we're trying to find. We're trying to find the x, but as of right now, we would have two unknowns, and that's not okay, right? So we would have to try and do something in order to find this v right here, okay? Well, what could we use to try and find that v? Well, from up here, we've got another formula at play that says that v equals v sub 0 plus at. Well, look, we're trying to find this, so we could plug it into this formula down here, which would allow us to find displacement. Well, we know the v sub 0, that's good. We know our acceleration, that's good. And we know our t. So really, we could use this formula of x equals 1/2 v sub 0 plus v times t, except we need to find this v first. Well, we can do that using this formula here. V equals v sub 0 plus at. So that's actually what we're going to do in the next page. We're actually going to take those formulas and we're going to find our x. So let me go ahead and clear this out and head on over here to the next page so we can get back to some of our stuff here. And what they're going to do is they're going to jot down everything that they know, just like we did. 2, 6, 8, they're trying to find x. And they're going to go ahead and they're going to find the x equals 1/2 v sub 0 plus v times t. But they're actually going to make it just a little bit more difficult because they're going to plug this whole formula in up here. And then they're going to get to a big, long, complicated formula, which is fine. We could do that. But what I would recommend doing is I would recommend doing this. I would say, all right, well, let's stick with the v equals 1/2 v sub 0 plus v times t formula. Except before you try and use this formula, we're going to find this v off here to the side using v equals v sub 0 plus at. So v is going to equal, our v sub 0 was 2 meters per second, right? No, let me go back and look for 1 second, because that, you see what our v was in the last page there. Sorry about that. Our initial velocity, our v sub 0 was 6. My mistake. Okay. So this v sub 0 will be 6. So 6 plus our acceleration was 2 and our time was 8. Okay. And let's go back and just make sure that we have all those numbers correct. Okay. So here you go. V equals v sub 0 times at. Initial velocity being 6. There it is. Constant acceleration 2. Time of 8. Perfect. Okay. And so basically what you're going to do is say v will equal 6 plus 16. Right. So your velocity is going to equal 22 meters per second. And now you can come back up here. Oh, actually, way up here, I made this mistake. Sorry about that. This isn't v, this is x equals. Just change that. My apologies. So x equals 1/2 v sub 0 plus v times t. This is what we're going to use. But we're using this formula to find v. So now x equals 1/2. Our v sub 0 we said was 6. Plus we found our v to be 22. And our t was 8 seconds. Okay. So now if we go ahead and we actually do this math, right, this would be 22 plus 6 is going to be 28 times 1/2. Let me get rid of this bottom portion down here. Times 8. So x is equal to 14 times 8. And therefore x will equal approximately, because let's see, 14, 8, 2, carry my 3, 1, 1, 2, so there it is, 112 meters. Okay, that's how you do that sort of a problem. So sometimes you got to look at all that you know and all that you're trying to find, and in some cases you're going to have to do some preliminary work even before you can find the actual problem that you're trying to focus on. So you're definitely going to want to put all of these equations, all right, on your formula sheet. So these are the equations of kinematics for constant acceleration. Okay, so make sure those are on your formula sheet.